Okay, so this is the last page for the unit review for Unit 3 test. And what we're going to be looking at is probably the most complex, the hardest part. If you pay attention and you review the first sheet and you continue to review the examples they give you, you'll be fine. If you're still confused, please see me. So we start with definitions. Please match them up with the correct word. So we start with an independent path in a parallel circuit. This is called a branch. And then we have, I'll call this A over here. And then we have a device that breaks to protect against excessive current must be replaced. That is called a fuse. Where branches join or split, and that's called a junction. Remember, it actually kind of looks like a T. Either way, a T upside down or right side up. Protects against high current but can be reset. This is what most of us have in our houses. This is a circuit breaker. Where most electrons in a circuit come from, that is the wire. They're coming from the wire. The battery pushes out the electrons, but the wire actually pushes them along. And then finally, we have the product of voltage and current. So it's voltage times current equals power, and that is F over here. Okay, the next thing is asking us about what would happen if we have 35 amps of current going through a 40 amp fuse. The current will flow. It'll be fine. Current flows. Nothing happens. Nothing. What happens? Absolutely nothing. 25 amps of current going through a 15 amp fuse, not good. The fuse breaks or melts. And now they're going to ask us, this is a word problem, so we're going to underline any numbers we see and then the unit after it. So this is 60 watt, which indicates power, and 120 volts indicates voltage. So we're figuring out current because this is I. So we just need the right setup for the formula between V, I, and P, which happens to be I equals P over V, which equals 60 watts divided by 120 volts equals 0.5 amps. And that's our answer. Remember to always box in your answer and make sure it has a unit right there. Now we're going to take a look at some parallel circuits. It says, how many branches does this circuit have? And it has 3. And it kind of tells you, because it says B1, B2, B3. So we're going to label them. B1, B2, B3. And then how many junctions does it have? So a junction has to be like a T. So there are 4. And it says circle them, which we did. Done and done. So now we're going to look down here. It says, what do we know about the voltage across each branch? So the voltage we have here is we have 2 amps running down this branch, 2 amps, and then 4 amps. So the voltage is going to, first of all, be the same. Voltage, the same. And then we have to find the total current. So total current is basically you add them up. So we have 2 plus 2 plus 4. So we have 2 amps plus 2 amps plus 4 amps equals 8 amps. The key actually says 6 amps, but that's not correct because It's not 2 plus 2 plus 2, but 2 plus 2 plus 4, if anyone notices that. So it's 8 amps. We're going to go across here to this parallel circuit, and we're going to look at the volt total, and all you do is add up the batteries. There's 2 batteries, and they're going to equal 3, because 1.5 plus 1.5 is 3 volts. How many branches are there? There are 3 volts going through each branch. This does not change at all. And then we're looking for the current that runs through branch 1. So current is basically voltage divided by your resistance. So in this case, it's 3 divided by 1, which is 3. So we're going to write I, resistance for branch 1, is 3 over 1 ohm equals 3 amps. And then for 2, it's exactly the same thing. 3 over 1 amp equals 3 amps. And so the total, all you do is add them up. So the total is 3A, 3 amps plus 3 amps equals 6 amps. And then the resistance total would be 1 ohm plus 1 ohm. Actually, your resistance total is voltage divided by amps. So it's your voltage is 3 volts divided by 6 amps equals 0.5 ohms. And then our power is your current times your voltage. So the current, total current was, it's I times V equals 6 amps times your voltage, which is 3, and you'll get 18 watts. 18 watts. And then I'm going to move this up a little bit. Okay, how much power, I'm moving over to this side, how much power is used by a 120 volt circuit using 6 amps? So we're going to use the formula for power, which is P equals voltage times resistance, and it is 120 times, I'm sorry, not voltage times resistance, it's voltage times current, and it's 6 amps, and that equals 720 watts, which is pretty strong. That's a lot. A 240 volt circuit has 20 amps. How much power does it have? So we're looking for P. P equals what? So again, same setup. P equals VI. This and that together mean the same thing. It's just multiplication. It's your voltage times your current. So our volt is 240 times 20 amps. This one happens to be even larger than the last. And we get 4,800 watts. We're going to take a look again at some circuits here. They want to know if it's series or parallel, which I actually forgot to do up on this one right here. This is definitely a parallel because it has 2 parallel branches. Okay, this one also parallel. and this one also parallel. So the volt total again is when you add up the batteries. So we have basically 3 plus 3, 3 volts plus 3 volts equals 6 volts. The branches, they're each going to get 6. So it's 6 volts across each. The current for the first one is, basically we're looking at resistance, which is in ohms, and your voltage. So if you go up here again, like we did, you can see that current is voltage divided by resistance. So right here, we're looking at voltage 6 divided by resistance, which is 3 ohms, equals 2 amps. And then in the second one, we have 6 volts, because again it's the same, over 6 ohms, and this is 1 amp. And then the total for this is going to just, basically you add them up. So it's 2 plus 1 is 3 amps. 2 amps plus 1 amp. And then your resistance total is where you take your voltage across the entire thing and then your current total, and it's basically voltage divided by current. So it's going to be 6 volts divided by 3 amps equals 2 ohms. Get that little symbol in there. And then again, power is V times I. So it's going to be your voltage, which is 6, times your resistance, which is 3, which is going to be 18 watts, which I'll put down right below. Okay. And let's go up to this one right here. So our volt total, add up your batteries, and it's 6 plus 6 equals 12 volts. Our volt branches, each branch here is going to receive the same amount of voltage, so it's 12 volts. Our resistance, our current for the first branch, we're going to again do it the same exact way where we have voltage divided by resistance. So it's voltage divided by resistance equals 12 divided by 6 equals 2 amps. And again, this is volts, and this is ohms here. I got it from here. And then this was the volts. And then your current for the second branch, you can see that the resistance is 3 ohms, and the volt is the same. So we have V over R. It's 12 volts divided by 3 ohms. 12 divided by 3 is 4 amps. And then your current total is, basically you just add these up. So it's 2 plus 4. So you have 2 amps plus 4 amps equals 6 amps. That's what we're looking for. And then we're looking for your resistance total, which is your total voltage divided by your total current. So we have 12 volts divided by 6 amps equals 2 ohms. And then finally, again, we're going to figure out the power throughout this particular parallel circuit. And it is your total current times your voltage, which is 6 amps times 12 volts equals 72 watts. And let's go on to the next one. So we have volt total. Again, add up your batteries. That's 24 volts. Branches, voltage branches get the exact same, 24 volts. And your current in your first branch, again, we're taking the voltage divided by the resistance. So we write this. I might as well go ahead and write these down here. Makes it easier. And voltage is 24. The resistance for the first one is 12 divided by 12 ohms. This is volts. 24 divided by 12 is 2, so it's 2 amps. And then we have, again, for the second one, we're looking at 8 amps, and our voltage remains the same, so it's 24 volts divided by 8 amps, which leaves us with 8 ohms, which leaves us with 3 amps. And then we're looking at the last one, which is same as the previous, so it's 24 volts divided by 8 amps, or ohms, I keep saying that, 8 ohms, which is the resistance, equals 3 amps. Oh, I turned off my pen. And then you add them together. So it's 2 plus 3 plus 3. So we have 2 amps plus 2 amps plus 3 amps gives us a total current of 4 and 3 is 7. Is that right? 2, 3? No. This is 3. So it's 2 plus 3 plus 3. So this is 8 amps altogether. So to find the resistance, we take the voltage divided by the current. So it is voltage divided by current equals 24 volts divided by 8 amps equals your resistance, which is in ohms. So your resistance is 3 ohms. Your power is the current, which is I, times the total voltage. And our current is 8 amps. So it's 8 times 24. This is going to be a big number. Equals 192 watts. 192 watts. And then we're going to move down a bit and we're almost done. So the next part's the lab, which we don't have to do. Okay, so let's start here. Volt total. Add up your batteries. So it's 3 volts plus 3 volts equals 6 volts. The branches receive the same amount, 6 volts. We're looking for the current, and so we find the current by taking the voltage divided by the resistance, and that is going to be 6 volts divided by 4 for the first, 4 ohms, which gives us kind of a funny number, 1.5 amps. The next one, voltage divided by resistance, so it's 6 volts divided by 6 ohms, and this is an easy one. This is going to be 1 amp. And then the next one is going to be lower than a whole number, so it's V divided by R equals 6 volts divided by 12 ohms. So we're going to get 0.5 amps because 6 divided by 12 is 0.5 or 50%, right? So your total is 1.5 plus 5 is 2 is 3 amps. So we have 1.5 plus 1 plus 0.5 equals 3 amps altogether. And then our resistance total, it is V over I, or V divided by I, which is voltage divided by your current. And so it is 6 divided by 3, which comes up with a nice number of 2 ohms. And then power, again, is just the current times the voltage, tells you kind of how strong it is. And so this is 3 times 6 is 18 watts. 18 watts. And you know where you see watts all the time, right? On the light bulbs. So that'll tell you how much power the light bulb, or how much heat or light radiant energy it'll put out. And now we're on to our last one. They're asking for the volt total, which is how much battery strength the battery has. And so it's 6, there's 2 batteries. So we have a total voltage of 12. There's 12 volts across each branch. Your current, again, is your voltage divided by your resistance. So voltage is 12 in the first one, and it's divided by 12 ohms, which is equal to 1 amp. And the second one, you already see there's 4 ohms of resistance. So it's going to be 12 volts divided by 4 ohms equals 3 amps. And then your current total, just add these guys up. So it's 1A plus 3A equals 4 amps. Your resistance, again, is taking the total voltage divided by the resistance. And that is 12 divided by 4 equals 3 ohms. Power, finally, lastly, is current times voltage. So we have 4 amps times 12 equals 48 watts. 48 watts. So please, if you look at these, they're actually, it looks like a lot. It's really not that difficult, but you do have to study for it. Please study for it. Re-study for it. And do your best. And the tests will be very similar. Our unit tests will be very similar to what we've been going over on these papers. Okay, good luck. Do your best. Study, study, study.